Alright, here's the review for logarithms and on. Number 50, do you know how to graph a logarithm? So we're going to start with two parent points. So the parent is just the logarithm with base 4. So for every logarithm, the parent is 1, 0, and then whatever the base is, n1, and then the asymptote is x equals 0. That's the parent. We're going to transform and make the butterflies. Inside the parentheses, we do the inverse of what we see. So instead of adding 1, we're going to subtract 1 to each x. And then to the y, we're going to multiply it. Subtract 1. We're going to multiply it times 2. So 2 times 0, 2 times 1. And then we're going to graph those. So 0, 0, 3, 2. And we have an asymptote at negative 1. And then a logarithm, the range is all real numbers. So it goes forever up and forever down. So concave down through those 2 points. Know the curve of a logarithm. The domain goes from, what is it, 0? No, the asymptote, negative 1. So it goes from negative 1 to infinity, not including negative 1. The range is all real numbers. And then the end behavior, as x is approaching infinity, f at x approaches infinity, as x approaches negative infinity, doesn't approach negative infinity. So as x approaches negative 1, the asymptote, f at x approaches negative infinity. Can you solve a log equation? So the logarithm's isolated. To solve this, we're going to write it as an exponential. So inside the logarithms, x subtract 2, the base is 6 and the exponent is 2. That means that x subtract 2 equals 36, add 2, and you have your answer. Make sure that when you plug it back inside the logarithm, it's not negative or 0. And 38 is a good answer. Here we'd write x squared subtract x equals 6 to the exponent 1. It's a quadratic, so make it equal to 0. So I subtracted 6. Factor it. The two numbers that factor are negative 3 and positive 2. So the solutions are positive 3 and negative 2. So when I plug in positive 3, I get the answer 6. When I plug in negative 2, I also get the answer 6, because the negative times the negative is positive. So it becomes 4 plus 2. Anyways, both answers are good. Neither one makes the inside of the logarithm negative. One more. This one requires a calculator. To get x by itself, first step is to divide by 3. Then I write it as a logarithm. Now, the base is e and the exponent is 9. And then the last step is to divide by 4. So e to the 9 divided by 4. So that answer is approximately 2025.771. The formula d equals 8e to the negative 0.404h can be used to find the number of milligrams d of a certain drug. So d stands for the number of milligrams in h hours after the drug has been given. When the number of milligram reaches 4, the drug is to be given again. So what's the time in between? So I'm going to plug in 4 for the number of milligrams. And then I'm going to solve for h. So I'm going to divide by 8. 4 divided by 8 is a half. I'm going to write this as a logarithm. So the exponent is negative 0.04h. The logarithm is ln, that has a base of e, and goes inside is 1/2. And then the last step is ln 1/2 divided by negative 0.04. So ln 1/2 divided by negative 0.04. So the answer is 17 hours, just a bit, a little more than 17 hours. Number 55. Between 7 and 8 a.m., a train arrives at a subway station at a rate of 12 trains per hour, the 0.2 trains per minute. The following formula from statistics can be used to determine the probability that a train will arrive within t minutes of 7 a.m. So determine how many minutes are needed for the probability to reach 20%. So the probability is 20%. And we need to solve for t, how many minutes. So I'm going to subtract 1. I'm going to divide by -1, which makes it -19. And then I got to write this as a logarithm. So the exponent is -0.2t. The logarithm's ln, and inside is -19. We can't have that. What did I do? So let me look again. So a train arrives 12. The following formula can be used to determine. So t minutes of that. How many minutes are needed for the probability to reach 20%? Let's see. How about we try this? Instead of writing it as a whole number, let's write it as a decimal. So 0.20 for 20%. So that when I subtract 1 from 0.20, I get -0.80. So that when I divide by a negative number, I get positive 0.80. I like that much better. So we have -0.2t equals ln of 0.80. So it wasn't clear to write the decimal as a percent or percent as a decimal. But the other way, you get an answer that's undefined. All right, and then the last step is to divide by -0.2. So ln 180, or ln 0.8, divided by -0.2. So how many minutes are needed for the probability to reach? And the answer is 1.115 minutes is needed. All right, number 56. Use properties of logarithms to find the exact value of the expression without using a calculator. So in this one, I'm going to write it as one logarithm by dividing. So subtracting means I should divide. 24 divided by 6 is 4. And 4 to what exponent equals 4? And the answer is 1. Here, you have e and then ln 13. Now ln has a base of e. So one of the properties of an exponential and its logarithm is that they are inverses of each other. So they undo each other, and the answer is just 13. This is going to be similar. I'm first going to go 28 divided by 4. So I can write it as one logarithm. Now I know 28 divided by 4 is 7. And when you don't see a base, the base is 10, and this base is 10. So the exponential and the logarithm with the same base, they're inverses. They undo each other, and then your answer is just 7. All right, can you write as the sum and or difference of logarithms? So can I expand this? So let's just start one at a time. So log base 14. So I have 11 multiplying, so I can add, and then again base 14. Now root set r, I'm going to write as r to the 1/2. And then when I'm dividing, I'm going to subtract. Same base each time. The only thing I can do here for one more step is that 1/2 can be a product in front. Here, can you expand this logarithm? So again, when I see an exponent, it's written in front. When I see dividing, it's subtracting. So the exponent is in front. Make sure you put the base down both times, and you fully expanded it. Turn the page. Can I write that as a single logarithm going the other direction? So the number in front becomes the exponent. So Q has an exponent of 3. R has an exponent of 4. And when you add, it means you're multiplying them together. 62. Again, I want to write it as one logarithm. So the 5 is the exponent on x. And subtracting means dividing. Notice the exponent on y here would just be a 1, so we don't need to write it down. 63. You're given a function that models the average number of free throws a basketball player can make consecutively during practice as a function of time, where x is the number of consecutive days the basketball player has practiced for 2 hours. After how many days of practice can the basketball player make an average of 5 consecutive free throws? So that's my answer, 5 consecutive free throws. And what I need to do is solve for x to know how many consecutive days does he need to practice or she needs to practice so that that can happen. So we're going to subtract 1. We're going to divide by a 1.5. So it's a calculate question. 4 divided by 1.5. That's 8 over 3. Now I'm going to write it as an exponential. So what's inside the logarithm is x plus 1. The base you don't see is e, and the exponent is 8/3. And then I subtract 1, and then I'm going to use my calculator. So e to the exponent 8/3, and then subtract 1. So then you get your answer. So after how many days of practice can the basketball player make an average of 5 consecutive free throws? And the answer is after 13 consecutive days, you could expect that. 64. Can you solve an equation, exponential? So step 1 is, can you make common bases? And the answer is yes to this. So 3 to what exponent is 243? And the answer is 5. And then take the exponents only and make them equal to each other. Subtract 1, and then divide, and you get your answer. All right, some stories to do with growth and decay. $14,000 is invested at 14% compounded semi-annually after a period of 13 years. How much do you get after that? So the formula is 14,000 P, then it's 1 plus the interest rate divided by semi-annually, 2 times a year, and that's for 13 years. So 14,000, 1 plus 0.14 divided by 2, and that's to the exponent 26. So that's $81,302.94. $480 is invested at 9% compounded quarterly. So 0.09 quarterly is 4 times a year, and then it's 5 years. So 480, 1 plus 0.09 divided by 4, and that's to the exponent 20. and you get $749.04. $5,000 is invested for 6 years at 5% compounded continuously. So for compounded continuously, we're going to use PERT. And how many years? 6 years. So 5,000 times E to 0.05 times 6. And you get $6,749.29. A little different. To get 10,000, so the end amount is 10,000. 4 years at 18% compounded monthly. So to compound monthly, that's 12 times a year, and it's 4 years. So to get P by itself, you just have to divide. So it's 10,000 divided by 1 plus 0.18 divided by 12, and that's 48, 12 times 4. And you get the answer, 48,000. No, 48,000. I gotta read numbers better. $4,893.62. What principal invested at 8% compounded continuously for 4 years will yield 1,190. So the end amount is 1,190. I don't know P. The interest rate is 0.08 compounded continuously for 4 years. So again, I just need to divide to get P by itself. So 1,190 divided by E to the 0.08 times 4, and then have the calculator skill to be able to type that in. So 1,190 divided by E to the exponent 0.08 times 4. See if I can read a number this time. $864.12 is what you would need to begin with to get that at the end. Turn the page. How long will it take for an investment to double in value if it earns 6.75% compounded continuously? Well, if it doubles, that means when I divide by P, so A divided by P, if it doubled, would equal 2. That's what it means to double. So that means 2 is equal to E to the RT. So that's 0.0675, and I'm solving for T. So I need to write that as a logarithm. So the exponent is 0.0675 T. The logarithm with the base E is ln, and then what goes inside is 2. And then divide by 0.0675. And that's it, ln 2 divided by 0.0675. So how long would it take? To 10.269 years. That's how long it would take to double your money. How long does it take 1,125 to triple if it's invested at 7% compounded quarterly? So in this case, it doesn't even matter how much money you start with. Triple means we're going to start with 3, and then we're going to write down the compounded quarterly part, no P. So that would be 1 plus 0.07 divided by 4, and then 4 to the T, because that's what I'm looking for. So I need to write this as a logarithm. So it might be helpful to take the base and write that as a decimal. So this means the same as 1.0175. So I just put that in the calculator to the 4t to make it easier to write as a logarithm. So the exponent is 4t. The logarithm has that base, 1.0175 1.0175, and then inside the logarithm is 3, and then the last step is to divide by 4. So we write down the log. So with the 89, it would be ln 3 divided by ln 1.10175, and then you take that answer and divide it by 4. What do I get? So I get t equaling 15.831 years. So to triple your money with that interest rate, it would take almost 16 years. A small herbivore population obeys that function. If they have enough food and so on, after how many years will the population reach 3,600? So first I set it up with the equation given. No, I'm solving for t. So step 1 is to divide by 900. That goes in evenly. That's 4. Then I need to write it as a logarithm. So the exponent is 0.22t. It's ln, and what goes inside is 4. And then divide by 0.22. So ln 4 So ln 4 divided by 0.22. So that's 6.301, and that's in years. Back to black-nosed rabbits. In 1990 and 1993, they tagged a 180. And then it says it follows the exponential law, which is PERT. So in this situation, we start with 90 rabbits. We don't know the rate they're increasing, but it takes from 90 to 93. So 3 years, it becomes 180. So I'm going to solve for the rate first. Divide by 90, and you get 2. And then you need to write it as a logarithm. So the exponent is 3r, the logarithm's ln, and inside is 2, then divide by 3. So ln 2 divided by 3, and you get 0.231 and so on. I'm just going to save that in my calculator. And then I go back and it says how many rabbits will be in the range 7 years from 1990. So in this case, if I want to know how many rabbits there'll be, I started with 90. The rate is 0.31. And then 7 years have gone by. So again, I'm going to save that. I'm going to save that full decimal in my calculator. Then I'm going to go 90e, and then I'm going to paste times 17. Not 17, 7. And I get 400, and if I round it, it's 454 rabbits at that rate. The bacteria in a container quadruples every day. If there are initially 100 bacteria, write an equation that models the number of bacteria A after D days. So we're starting with 100 bacteria. It's increasing. Now the rate that it's increasing by, if it's quadrupling every day, is 400% is quadrupling every day. So as a decimal, that would be just 4, quadrupling. and then the exponent would be d. In fact, I don't even need the 1 there. So it's 100 times 4 to the d. So on the first day it quadrupled, so you go 4 to the 1. So it's 100 times, and then if it quadrupled again, you go times 2, and so on. It says how many bacteria will there be after 1 week? So after 1 week, that's 7 days. So it'd be 100 times 7. So 100 times 4 to the exponent 7. That'd be 1,638,400 bacteria. A culture of bacteria obeys the law of uninhibited growth. If 140,000 bacteria are present initially, 609,000 after 6 hours, how long will it take for the population to reach 1 million? So this is a PERT question of the law of uninhibited growth. So we started with 140,000. There are 609,000, and that is after 6 hours. So we need to find the rate per hour. So we're going to divide. And then we're going to write it as a logarithm. So the exponent is 6 times r, the logarithm is ln, and inside is that fraction. And really, I don't need the zeros at the end. I'm going to divide by 6, and that will give me the rate. So ln 609 divided by 140, then divide that answer by 6. Again, I'm going to save that in my calculator. 0.245 is approximately the rate we're going to use. Then I go back to PERT. And again, we have 140,000. And now we have the rate, and now I'm solving for t. Oh, and the end amount I know is 1 million. So I know what that is now. It's 1 million. So I'm solving for t. So step 1 is to divide. So I can knock off a bunch of zeros. So divide it, and then we end up with 100 over 14. That's fine. Write it as a logarithm. So the exponent is 2.245t. That's the logarithm, base e. And then what goes inside, I'm left with 100 over 14. And then the last step is to divide. So ln 100 over 14. And then divide it by 0.245. And then the answer is about 8 hours. 8.0 whatever. So in about 8 hours, it'll be 1 million. So 2 more hours after 6 hours. So this is a present. So 2 more hours, you could say, after 6, or you could say from the initial, it's 8 hours from the initial, how much were present initially. Turn the page. Half-life questions. Half-life of silicon is 710 years. 30 grams are present now. How much will be present in 200 years? All right. So we have how much present now? 30. Half-life, it's going down by that. Every 710 years. So in 200 years, how much is left? I'll show you another way you could do it too. So the amount that's left of the 30 grams is 24.679. That's the quickest way to do it, to set it up. Understanding half-life being the decay rate. That R is 0.5 and it's decaying. Another way to understand it is you could find your rate by solving that, and then once you have that answer, you would then, and so you would divide by 30, that would give you a half. You'd have to do the 710th root of 1/2. And then you'd add R and subtract that ugly root. And then once you had that answer, you would then plug that answer back in here. So whatever that answer is would go in there. And then the exponent would just be 200. And that would give you the same answer. Alright, so I'm going to use the simpler method rather than the one that takes all these steps. But both give you the same answer. Plutonium is 9 hours. That's the half-life. So every 9 hours. There's 70 milligrams present now. How much will be present in 5 days? And 5 days is the same as, so 24 times 5, 120 hours. So times 24. It has to be the same unit. So the shortest way to do this is that you started with 70 milligrams. The decay rate is 0.5, so we're subtracting. So it's every 9 hours, so that's divided by 9. And then in 120 hours, how much is left? And the answer is 0.007 or 678 and so on, but rounding it would be 0.007 milligrams. Again, it's radioactive. It's decomposing quick. So the half-life of a radioactive element is 130 days. So again, we got that half-life. It's decaying. And that's the rate every 130 days. Your sample won't be useful to you after 80% of the radioactive nuclei originally present have disintegrated. So about how many days could you use the sample? So I'm not given what it is, right? And so you can think of this formula in terms of half-life, where I created that fraction with 130. When I divide this by P, that A divided by P has to be 80% of what's left. And again, I don't know what T is. That's what I'm trying to solve. So when you go A divided by P, that's 80%, and we write that as a decimal. Kind of like when we doubled or tripled. How long would it take? Now, how would I solve this? I'd write it as a logarithm. So it'd be helpful to write this. First of all, 1 take away 0.5 is 0.5 to that exponent. As a logarithm, the exponent is that. The logarithm has a base of 0.5, and inside the logarithm is 0.80. And then, to get t by itself, we multiply that answer by 130. So, in our TI-89, we go 130, and then it would be ln 0.80 divided by ln 0.5. So we changed the base so we could use our calculator. And then the answer would be 41.85 days, or about 42 days. After 42 days, there's less than 0.80% left. All right, last one. The half-life of radium is 1,690 years. 150 grams is present now. How long to the nearest year till only 100 grams are present? So we started with 150. We're decaying at a rate of 50% per 1,690 years. And our end amount is 100. And I need to solve for t. So divide by 150. One take away 0.5 is 0.5. Next, I need to write it as a logarithm. So the exponent is that the logarithm is going to have a base of 0.5, and then inside the logarithm would be 10 over 15. So to get t by itself, it would be 1,690 times, and again, on our T99, we go ln 10 over 15 divided by ln 0.5, and now use your calculator. And the answer would be 900. So how long till only 100 grams are present? And the answer is rounded to the nearest year would be 989 years. All right. You have studied and worked to do well on the exam. GMath, over and out. I'm proud of you.